So now we'll start with the other properties. So before we go to the next reaction, I want you guys to, like, I would just want to discuss one more thing. We have to talk about like both metals and non-metals, right? A little bit short note about oxidation of non-metals. Okay. So what do you get when a non-metal reacts with oxygen?
Ma'am, non-metallic oxide.
Non-metallic oxide. Definitely, that's absolutely correct. And what is the nature of non-metallic oxides?
Basic.
Ma'am, acidic.
Acidic.
Okay.
So metallic is basic, non-metallic would be acidic in nature. Okay, like think of carbon dioxide, think of sulfur dioxide and nitrogen oxides. So if you mix them in water, you're going to get your acids. So non-metallic oxides are acidic in nature. Okay. Some examples, common non-metals. So carbon plus oxygen will give
CO2.
Awesome, correct. CO2. Nitrogen plus oxygen will give
NO2.
NO2 is one of the many oxides that it gives. Sulfur plus oxygen gives
SO2.
SO2. Yeah, those are some common non-metals. The non-metallic oxides, when you dissolve them in water, you get acids. They're all acidic in nature. Okay, just a little note about it. Most of them are gaseous. All of these are gaseous. What else do we know about non-metallic?
Ma'am,
Yeah.
ma'am, can't they be aqueous also?
No, because like non-metallic oxides, all of them are covalent compounds, right? So they form like individual molecules that escape out as gases. If it was like ionic, then it forms a salt, then it dissolves in water, then you get like solid powder, or if you're using like water, then it becomes aqueous. But these just escape as gases. This is what makes up smoke, basically. Okay. Yeah.
So ma'am,
And do you have
most
to write this?
oxides are gaseous, right?
Non-metallic oxides, most of them are gases, yes.
Okay.
And do we have to write this?
Yeah, make a note of it just in case. It'll be good info for you guys. This is important. This part is important. Examples, yes, you can note it down. As always, should be balanced. But yes, non-metals, when you burn them in air, when you heat them in air, you get non-metallic oxides, and non-metallic oxides are acidic in nature. Metallic oxides are basic in nature. So this is an important fact. Okay. Okay, you guys noting this down, or like can I flip to the next screen?
Noting.
Ma'am, I'm
Noting, ma'am, still writing.
Okay.
Ma'am, done.
Done? Okay, Nancy's also done.
I'm writing.
Writing, okay. Cool. So Jasmine, Elena, Puneet, Vasudha, Jaden, Avika. Okay. Yes, give some sort of indication when you're done. Okay, then I'll flip. Next one. Dhruv is also done. Okay. Shakti is done. Aditya is done. Sarah is also done. Okay. Anisha is done. Rishita and Aditya also done. Krishna has also done. Abhishek is done. Ryan is done.
Done.
Okay, Vidya is done. Nikki is also done. Amay, let me know. Snehal, didn't hear yet to write. Okay, Snehal is also done. Okay. So Amay Songhaskar, let me know when you're done and then we'll go. Okay, let's go. So yeah, so we're done with reaction with oxygen. We've seen what is the nature of products that you get, and also we've seen that different metals react in different ways. Like sodium, magnesium are pretty reactive, but when it comes to iron and all, barely reactive. Copper needs to be heated for any reaction to take place. Gold, silver, though they don't react at all, like not at all. Okay. Next, reaction with water. Okay. So for reaction with water, it'll help if, like you guys can roughly remember the reactivity series. Okay. So let's just write down the reactivity series. It'll be kind of easier to figure out how these metals react with water. So what comes right at the top, reactivity series mein, most reactive?
Sodium.
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 So potassium and sodium are right up there. Iske baad,
Lithium, I guess.
lithium, Shah.
Magnesium.
Magnesium, yes, magnesium is one.
Calcium.
Calcium.
So
Calcium.
magnesium,
Aluminium.
aluminium, yes.
Zinc.
Uske niche,
Carbon.
Iron.
iron. Yeah.
Tin.
Tin, okay. Tin,
Lead.
here lead is also there, yes. और उसके नीचे
Hydrogen.
hydrogen is like the dividing point, okay. Hydrogen के नीचे you get copper,
Copper.
yes.
Silver and gold.
Gold.
Okay. So you can roughly divide it into the topmost being highly reactive. So these metals react violently with water. Okay. Vasudha has sent the acronym, like what, not acronym, the mnemon, like remembering thing also. Please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. Yeah. Okay, but coming back to this, these are most reactive. So they react like really enthusiastically, like they are very, very violent in water. These metals, in fact, catch fire. We'll see what, how, and all in a bit. I'll put the reactions also. Then coming slightly to the bottom, these are not as reactive. With cold water, they don't react. So they require, warm to hot water to react.
So they require heat, thermal something.
Yeah, so like they require heat. That is absolutely right. So violently they react with cold water. So if they react with cold water to hot water, you don't even have to say, like it is even more explosive with hot water. Calcium, magnesium, they don't react with cold water, like no effect at all. But when you start heating it, yeah, then they start reacting with water. And then aluminium also to some extent. And then below this, like when it comes to zinc and iron, they don't react with cold water, like they don't react with water in the form of liquid at all. Now, again, they're so far below in the reactivity series, right? So these require, they will react only with steam. Okay. So water in gaseous form, like boiled water, beyond boiled. So these metals will react only with steam. Okay. And once you go below, these few metals like copper, silver, gold, they like basically don't react with water at all. They're incapable of reacting with water. If you want to make them react with water, it needs to be like really extreme temperatures. You need to like really heat them or treat them chemically some other way to, get them going. So this is basically the order of reactivity with water. And it also, the kind of product they form also follows this kind of order in it. Okay. So when it comes to the metals that actually react with water in the form of water, like up to like potassium, sodium, calcium, and magnesium, these metals, when they react with water, can you predict what product will be formed? So Na plus H2O will give what?
Ma'am, NaOH.
NaOH.
NaOH, yes. So if you're unsure, like if you have to figure it out, think about it. What sort of ions does sodium produce?
Positive ions.
Positive ion.
Positive
So
one.
यहाँ से Na plus ion.
Positive.
H2O, if it has to split into ions, what will it split as?
H plus and O minus.
Two
H plus
plus.
H plus O minus.
O minus.
O2 minus.
O2
O
minus.
O2 कहाँ से आया?
O
H2
minus too.
water, H and OH.
O2 minus.
Oh, yeah.
HOH. Okay, so water say you get H and OH. That's why water is basically neutral, because it has equal number of H plus and OH minus, like not acidic, not basic, kind of like that. Okay. So based on these ions, now Na plus will be attracted to which species here?
Ma'am,
OH.
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 Minus.
OH minus. So positive attracted to negative. So one product is NaOH, and what will be remaining?
H2.
H.
So hydrogen gas is produced here. Okay. So that's like a characteristic of reaction of metals with water. They displace hydrogen gas. Okay. So whenever metals react with water, they form hydroxides and they displace hydrogen gas. So this is true with all the reactive metals. So calcium, like sodium, potassium, calcium, and magnesium. So difference is sodium and potassium will undergo this reaction with cold water itself. Calcium, magnesium, they will need the water to be heated, but still the reaction is still the same. When it comes to aluminium,
Ma'am, do you have to note the reaction also?
yes, please, but not right now. I'll give you guys time to note it down, but pay attention here for now. When it comes to aluminium, like from aluminium and below, what happens is when aluminium reacts with water, ideally, like if you follow the pattern, you need to get hydroxides. But aluminium, iron, these metals, no, they will directly produce oxides instead of hydroxides. Okay. So the reason is that, yeah, like during the reaction, ideally, like ठीक है, aluminium hydroxide will be formed. You have Al3 plus and you have 3 OH minus ions surrounding it. But one, because they are reacting with steam, right? So it is at a really high temperature that it makes this unstable, and it is like the oxide is more stable than the hydroxide. So the hydroxide is gonna basically like break down into the oxide, and hydrogen gas is displaced. Okay, so usually like the metals that react with steam give oxides as the product instead of hydroxide. Same with iron. Like even when iron reacts with H2O, you get iron oxides. So this is basically what happens during rusting also. So during rusting, it's a slow enough process. And rusting iron is not like iron along with oxygen in air. It is also reacting with the moisture that is present in air, like water vapor basically. Yeah. So what you get is a mixture of iron oxides represented as Fe3O4, but yeah, you get both Fe2O3 as well as FeO, and displaces hydrogen gas. Okay, so you can note it in this format because I think that it'll be easy to remember. If you want to split it in two different tables, like that also works. However,
So the
yeah,
okay, so ma'am, the weaker reactions, they produce oxides instead of hydroxide. That's what you're saying.
correct. Yes. Yes. And of course, like these reactions need to be balanced. They're not balanced yet. Like sodium ke case mein, needs to be 2, 2, and 2. Yeah. So complete the calcium wala reaction also. Note it down. So whatever I've put star mark in green, all of these metals follow the same reaction as the reaction I put in green. So they produce hydroxides. And whatever I've put, I did not put star mark, they will undergo the reaction in blue. That is, they produce the oxides. And the rate of the reaction, like if you, like this way, you'll also intuitively understand like the reactivity series also. It's easy to remember this way. Cold water se jo bhi react karta hai, highly reactive. We have sodium and potassium. Then calcium, magnesium, aluminium to some extent react with hot water. And everything below that, you need steam for them to react with water. Otherwise, they will not. Yeah, note it down. I'll line up some visuals for these reactions. Looks cool. In the meantime, yeah. So calcium and magnesium float in water on heating because they react with water and produce H2 gas, hydrogen gas. So as the H2 bubbles, stuck to the metal, float, they take the metal, or they cause the metal to float as well. Okay. So as long as you guys get the point of understand the concept of it, because think of it like from examination point of view, you guys are going to get either multiple choice or assertion reasoning, right? So more than presentation, make sure that you understand the reason properly. So in any way that it's presented, once you understand what is being said, you can answer based on that. Okay. Point is that you have metal. Metal has like bubbles stuck to it. And because these bubbles are rising, they take the metal along with them. That's how the metal also floats. So here you can say as the bubbles stuck to the metal rise up or rise in water, or you can say float itself. Yeah.
Done, ma'am.
So Jaden, Aditya are done. Elena is also.
Ma'am, after react, it continues with right?
After this, what?
After,
After react, it
they react with water and comma they cause the metal to float, right?
So from here, it goes. Yeah, I ran out of space here, that's why I continued over here.
Yeah, ma'am.
Okay. Sudha, Neet, Mansi, Bhavika, Jasmine. Any of you still noting?
I'm waiting. I'm done.
Done. Okay. Okay. Water. Okay, we got oxide and hydroxides are produced. Another point you may note it down, like reaction with water is also usually always exothermic. So in all the cases you've seen, bubbles, fire, yeah, reaction with water is exothermic.
Ma'am,
Yeah,
ma'am, the equation given over here is balanced, right?
yeah.
Okay.
Okay. So let me know once you guys are done with this, because after this, we'll be going to the next reaction, that is reaction with acids. Yes, done, okay. Ryan, Neki, Divya,
Yes, ma'am, I'm done.
done, okay. All right, I'm switching. If anybody is still writing, let me know. No answer, that means I'm switching. Okay. All right, so that was reaction with water. Next, moving on to reaction with acids. This is reaction number 3. Yeah. This we have already studied in the previous chapter. So half of it you guys only must be able to answer. So what do metals, like what products are formed when metals react with acids? Metal
Salt
plus
plus
acid.
hydrogen gas.
Very nice. Yes. Salt plus hydrogen or water?
Water.
Aisha? More people,
Hydrogen.
like
No,
one
hydrogen.
person, one person said water.
I'm changing to hydrogen.
Yes, hydrogen is correct. Yeah. So when you have only metal, where are you going to get the oxygen from, right? So it's only going to be salt plus hydrogen. So when it's metal oxide, that oxygen will stick to hydrogen and form water. Okay. So reaction with acids, metal plus acid gives salt plus hydrogen. We'll do a couple of reactions for practice. So send me the product. Zinc plus H2SO4 gives, send balanced equations. Okay, this time I'm not just looking for product.
Ma'am, you're giving chat, right?
Huh?
Ma'am, you have to give it in chat, right?
Yes. Copper plus yeah, 4 reactions. Again, balanced equations, you guys. Send the balanced equations. Good practice. Puneet, what is the valency of aluminum? Anirban, again, valency of aluminium and valency of chlorine, you kind of, I don't know, mishmashed it wrong. Jasmine, first one is correct. Got it. Devi, yes. Deshna, zinc equation is correct. Dhruv, zinc equation is correct. Aditya Rane, zinc equation is correct. Anirban, work it out properly. Like, figure out what is the valency of aluminium, what is the valency of chlorine. Crisscross method use karke figure it out. Okay. Oh, Dhruv, I had mentioned, right? Puneet, yes. Puneet, yeah, you corrected it. That is correct. Dhruv, aluminium is correct. Mansi, zinc is correct. Deshna, aluminium is correct. Anirban, no, like aluminium ka valency you got, but chlorine ka valency, you've made a mistake there. इसलिए गलत हो गया. Dhruv, copper is incorrect. Divya, aluminium ka aa gaya, that is correct.
Miss copper is center.
That is incorrect. Raghav, aluminium is correct. Shakti, zinc and aluminium, yes, you got it. Deshna, copper ka, that one answer is correct. Neil Prajapati, 1, 2 and 4 is correct. Copper se reaction is not correct. Anirban, copper ka reaction, no. Puneet, copper ka reaction, no. Jasmine, aluminium is correct. Elena, all except copper is correct. Vasudha sent on WhatsApp, I'll check it in a bit. Wow, 15 new messages, I need to speed up. Aditya Rane, aluminium is correct. Devya, you got, yeah, copper ka bhi, you got it right. Rishita, first two, oh, nice. That's a fun way of putting it, but you can also just write it in words. First 3, you got it. Deshna, fourth one, you got it. Puneet, yes, third, copper is correct. Raghav, copper is not correct. Shakti, copper is not correct. Abhishek Trivedi, zinc ka valency kya hai? Check again. So Abhishek, you need to like brush up on your valencies. Your concepts are right, but the formula that you're forming, usme galti ho rahi hai. So that will still cost you. Like even though you know the concept, you're losing out because of that. So keep revising that, Abhishek. Neil, copper answer is right. Aditya Rane, copper is not right. Anirban, Magnesium का valency क्या है? Nitrate का valency क्या है? The formula is wrong. Mansi, aluminium is correct. Aditya Mundra, you sent all 4. The third one is not correct. Ritvik Vishal, you sent for all 4. The third,
Ma'am, only the third one, right?
yeah. Divya, 4th, you got it. Jaden, yes, 1, 2, 4, the ones that you sent are all right. Jasmine, I think you sent the answer for the third one. Yeah, that is right. Rishita, HNO3 से anion HNO3 ही होगा क्या? Check that again. Magnesium वाला. Shakti, 4th is right. Raghav, now you got it. Yes, copper wala point, you got it. हाँ, Jasmine, magnesium wala is right. Okay. Since most of you have gotten a lot of the things correct. हाँ, Tanisha, I got your zinc का answer abhi. Awesome. Rishita, the 4th is right. Zinc and H2SO4. Abhishek Trivedi, let's do this again. Zinc का valency क्या है?
Two plus.
Yes. And sulfate का valency?
Minus.
That is -1, -2. कितना?
-1.
नहीं. You need to revise it. Sulfate is SO4 2 minus. Yeah, -2 होगा. Yeah. So based on this, the salt that you get from this is zinc sulfate, ZnSO4. And hydrogen is displaced. Aluminium, most of you have gotten it. That's AlCl3 plus H2 gas. This stumped a lot of you guys. Is copper capable of displacing hydrogen?
No.
No.
Will this reaction take place, like at least with diluted?
No reaction.
So I say no reaction. And magnesium nitrate, nitric acid, this is one of the exception cases. So that I'm just going to discuss in a bit. This is going to be MgNO3 twice. Magnesium ion, nitrate ion, NO3 minus, and H2 gas. Okay. So these are the answers. The ones who have sent on WhatsApp, I'm just checking it up. Whoever is noting it down, whoever has made a mistake, like correct it, note it down properly. Vasudha, I think, yeah. First, second, copper ka you need to correct it. The rest all you got it. And okay, Neki sent on WhatsApp. Yes. Oh, magnesium hydroxide ion kahan se aaya, Neki? So that you need to correct.
Yeah, I didn't get the last one because
Oh.
it's written metal plus acid is equal to salt, right? So is MgNO3 twice a salt?
Yeah. Salt is literally anything made of a positive cation and a negative anion. Like basically anything made of a metal or like ammonium, us tarah ka cation and a anion. So salt is like in this context, if you have metal plus acid, right? Metal will always be the cation, and acid may, if you remove H plus, whatever remains is your anion. So इसलिए sulfuric acid is H plus and SO4 2 minus. So SO4 से salt बन रहा है. H plus Cl minus, Cl से salt बन रहा है. Same thing in this case. H plus निकालो तो you get NO3 minus. So nitrate का salt बनेगा. That's it. You just have to split things into ions and rearrange them. That's exactly what's happening in the reactions. Yeah.
Ma'am,
Yeah.
yeah, ma'am. Can you please show the last slide for us just a second? Because I think I missed the last equation, something like that.
Which
Right.
one? Like water के साथ reactions.
Yeah, and that one.
So first four will form hydroxides like potassium, sodium, calcium, magnesium. Aluminium के नीचे से all of these will form oxides. So anyone's keen, you can add zinc के साथ reaction also on your own. Would be good practice. But yeah, this is the pattern.
Okay, ma'am.
And yeah, acids ke saath, this is the thing. The exception is that nitric acid. So nitric acid is HNO3, will not, like reaction of metals with nitric acid, metals will react with nitric acid, but they won't displace hydrogen gas. Okay. So they will react with nitric acid. All metals react with nitric acid, or the reactive ones. But the exception, or the fact is that बाकी सारे acids के साथ you have the hydrogen being released. Nitric acid के साथ H2 is usually not liberated. The reason is that HNO3, nitric acid, is an extremely strong oxidizing agent. Okay. And what is an oxidizing agent?
It gives oxygen or takes hydrogen.
Reduce oxygen.
It gives oxygen or takes hydrogen, right? Something that causes oxidation. So HNO3 oxidizes H2 into water, produces H2O. So along with water, you have many different oxides of nitrogen also released. Along with, like, produces H2O along with oxides of nitrogen. So oxides of nitrogen, matlab, it could be NO2, it could be N2O. NO is an oxide of nitrogen. There's N2O5. Now, which oxides or which set of oxides, it's difficult to predict because it changes from case to case basis. Like if you take strong nitric acid, then you'll get like multiple oxides. If you take like dilute, then you'll get, one of the lesser oxides. Maybe with some metals, you get some oxides. With other metals, you get all of them. Like it changes from case to case. Like you get a mixture of oxides. So there is no definite way to write a reaction with nitric acid. So metals react with nitric acid, but the difference is that in this case, H2 is not liberated. And the reason why hydrogen gas is not liberated is whatever hydrogen you get, nitric acid oxidizes it into water. Like it adds an oxygen and converts hydrogen to water. So along with it, it also oxidizes the nitrogen that's present there and produces like a mixture of oxides of nitrogen. Okay. So this is,
But the previous reaction, H2 is released or liberated.
that's a good catch, Nikki. So within this special case, there are a couple of special cases that specifically with magnesium and manganese, Mg and Mn. It follows like a normal metal ka reaction. So it displaces hydrogen gas. So specifically with these metals alone, you get hydrogen gas. Guys, whatever I'm writing on the bottom, is it visible or should I go to the next page?
Visible.
Yeah, ma'am, visible.
For everyone? Because it's right at the bottom.
Yes,
And
ma'am.
okay. So if anybody is not visible, let me know. I'll go to the next page. Okay. So exception is that, or if within the special case, there's an exception that magnesium and manganese, Mn is manganese. H2 gas is liberated. So that is the reason I have specifically put magnesium over here. It happens like normal. You get the nitrate and H2 gas. Raghav and Neil, you guys have your hand raised. Do you have any doubt, or was it for the previous thing, like you finished writing it?
I finished writing it, so I raised my hand up.
Okay. So again, like this has, like you may get this kind of question in assertion reasoning. So like make note of this. So special case, this happens only with nitric acid. Main point is that it reacts with metals. It's not that it doesn't react, it reacts with metals. The point is that H2 gas is not liberated. You don't get hydrogen gas. Instead, you get water directly. And the reason why you get water is that nitric acid is a strong oxidizing agent. So it oxidizes hydrogen into water. And along with water, like the gases that you do get in this reaction are different oxides of nitrogen. But within this, the exception is that with magnesium and manganese, like these specific metals, you still get the reaction. The reaction happens as per normal. Yeah. Are you noting it down? Can I go to next page?
Ma'am, done.
Done, ma'am.
So again, if we come back to the reactivity series.
Ma'am, 1 second. I was writing.
Okay. Is there anybody else also still writing? No, no one's writing. Okay. Again, like we're talking about reactivity series, right? So all these metals that I've taken examples of, zinc, aluminium, magnesium, these are reactive metals. They do tend to react, some more than others, depending on their reactivity. Now, copper is unable to displace hydrogen because it is less reactive. Similarly, along with copper, silver and gold are also like pretty unreactive. Platinum also. These are not very reactive at all. So they don't react with dilute acids. Like with your normal laboratory grade acids, they don't react. That said, if you take like an insanely strong acid, you know, something so strong, for example, there's this acid called aqua regia. Okay, so aqua regia is basically the mixture of HCl and nitric acid, HNO3, specifically in the ratio 1:3. So 1 part HCl to 3 parts nitric acid, or was it 1 part nitric acid, 3 parts HCl? Okay, this always confuses me. I need to just verify it. But yeah, it's a mixture of concentrated hydrochloric acid and nitric acid, taken in the ratio 1:3. I'll just tell you guys which one is what. Sorry, it's the other way around. So nitric acid is 1 part and HCl is 3 parts. It is corrected. So you have 1 part nitric acid to 3 parts HCl in this specific ratio. Both of these are really concentrated acids. not dilute ones. So this particular mixture is called aqua regia, and this substance is so strong that it can melt gold. It can dissolve gold.
Ma'am, in school you were told that it's used to clean up the tarnished silver.
Silver and gold, yes, because silver, gold, like these are basically unreactive, right? So if you, so this has a lot of uses. So one is to clean up tarnishes. Another uses when you're even in the extraction of gold. So gold, usually you get it in the native state itself, but it's not like 100% pure. So there'll be a lot of impurities. Again, if it's in the earth's crust, you'll have a lot of soil, you'll have like other metals mixed in it. All of this is there. So there's a specific process called leaching. So in the purification of metals like gold and silver, you use aqua regia. You essentially dissolve all the gold, and then you do another chemical process to get the gold out. Okay, so that is one thing. Fun fact about aqua regia. Have you guys heard of the scientist Niels Bohr?
Huh?
Yes.
Yeah. So he's a Nobel Prize winner, and all his research and all were in the 1930s, right? Like that's when structure of atom was discovered and all of that stuff. So World War II, have you guys studied about it in your history class? Like what happened during World War II?
Yes.
Yes, ma'am.
Yeah, so what happened during World War II?
Ma'am, like you're asking how it started and
And there was a
everything,
nuclear
how it
bomb.
ended.
No, like during World War II, what was like the social situation like? What happened? Or you just studied the causes, like what led to it and then how it ended up?
Yes, ma'am.
So what happened during World War II was Germany was coming into power. Like Germany was one of the superpowers that other countries were fighting against, right? And you had all of this Nazism thing where they were prosecuting and they were executing, like
So, ma'am, you're asking about
Jewish and Poles.
Jewish people, yeah. So what happened is, like during this, obviously people were not sitting quietly. Like people were emigrating to America, they were going to other countries to protect themselves, they were going into hiding. And obviously, like all the scientific community also, people were, some of them were disguising themselves. They were like selling off whatever they can. They're packing up their precious possessions and hiding their identity so that they can escape to a different country. So what happened is, like the Nobel Prize winners, obviously you have like, they get gold medals or trophies of the kind, right? And that is a pretty big giveaway. And scientists were even more, they had to be even more careful because a lot of these superpower countries were trying to hire them so that they can work on like nuclear weapons and all of that. And obviously some of them do not want to, like that's understandable. You don't want to contribute to destroying the world. You want to protect the world, right? So how do you deal with, having this pretty big identifier with you made of solid gold? You can't, like gold was a precious commodity. You can't like, it's pretty shiny, like people will want to take it, like people can steal it from you. At the same time, you don't want to keep it like a medal because that's a very good identifier. So how do you do it? So one of the scientists, what he did was he created aqua regia, melted all of that gold down, and that's how he hid it basically. Yeah, so that's like a fun tidbit history about, one of the ways that aqua regia was used. So this happened during World War II. So yeah, normally acids don't react with metals or the inert metals, the noble metals, including copper. But if you take acid in enough concentration, if you make it like really, really concentrated and really strong, it is capable of dissolving metals like gold and platinum also. In real world, like normally this is used in the industry, like this principle. You dissolve the gold and take away the impurities, and you do that reverse chemical process to get your gold back, like you crystallize gold back from the salts that you get. And yeah, that's how it's used. And as Raghav mentioned, also used in like cleaning the tarnish, like if you have generational gold, right, like really, really old ones, even that can get tarnished over time, so used for cleaning that. So this is all about reaction of metals with acids. We started off with general reaction, what usually all metals react with acids, they displace hydrogen gas. One exception in the acids is that nitric acid. It reacts with metals, it just doesn't follow the usual thing of producing salt plus hydrogen gas because it's a strong oxidizing agent. But within this, like magnesium and manganese have a way with it, they will undergo a normal reaction. And apart from that, you have like lesser reactive metals, they don't react with acids, with dilute acids, but produce a strong enough acid like aqua regia, and even those metals can be dissolved in it. Okay, so that's all about the reaction of metals with acids. Then finally, the last set of reactions is metals with other metal salts.
And this will be basically displacement reaction.
Correct. So in other words, we're talking about single displacement reaction.
After the statement of gold, we are writing this, right? I got disconnected.
I didn't get you, Aditya. Like what about gold?
The statement that's so strong that can dissolve gold. After that, we are writing this only, right?
Yeah. So that's all with
Okay.
with respect to acids. Now we're moving on to this. Okay. What else? Yeah, displacement reaction. Do you guys remember what is displacement reaction definition?
Yes, ma'am. Ma'am, a more reactive element displaces a less reactive elements from its compound.
Yes, absolutely. A more
Compound a solution.
From its salt, like if you had to be really accurate, you can say from its salt, from its compound. From its solution is basically, yeah, this reaction takes place in solution form. Yeah, you can say that. But yeah, a more reactive, like because we're talking about metals here, a more reactive metal or element, can be a non-metal also, displaces or replaces a less reactive metal or element, depending on the context, from its salt solution. Examples of displacement reaction. So the key here is, again, just like we discussed in the first chapter, more reactive can displace or replace a less reactive one. Okay. So for example, if you have sodium and you have, let's say, iron sulfate. So can you complete this reaction?
Na2SO4.
Na2SO4 plus Fe.
Yes, absolutely. So that displacement reaction. So balance the reaction. So a few more. Send your answers over chat again, as always. Yeah. So first one, we've done it. So second, third, fourth, yeah, send the thing. Anirban, hydrogen कहाँ से आया?
Must typo.
Mansi, yeah, the second, yes, got that. Ishna, again, a more reactive metal displaces a less reactive. Like you can search the reactivity series and keep it beside you either from chapter notes or from online if you need that help. Okay. Aditya Rane, yes, magnesium wala, you got it. Vasudha, magnesium and iron wala, I think that's, I'll ignore that. I think that's a typo. Shakti, you also keep the reactivity series with you. Puneet, iron and aluminium, yes, we got that, correct. Anirban, keep the reactivity series with you again. Shakti, that is not the complete, like give me all the products that are involved. Mansi, yes, iron wala is correct. Baad mein you sent it, that is correct. Jasmine, check the reactivity series. Shakti, magnesium wala, you corrected it. Anirban, फिर से hydrogen gas. Focus. We are done with acids. See what we're doing now. Like focus here. Vasudha, iron wala, you got it. Baad mein, yes, you corrected it. Neki, yes, magnesium is correct. Bhavika, keep the reactivity series with you. Otherwise, the other two are correct. Aditya, yes, the iron and copper one. Iron and copper, interesting. Okay, so like in this reaction, right? Fun fact, Fe is going to stay in +2 oxidation state only. Like sulfate is 2-, copper is +2. Fe also, when it displaces, it stays in the +2 oxidation state. Okay. Then Mansi, you got the aluminium one. Vasudha, you got the aluminium one. Elena, magnesium is correct, iron is correct, aluminium is correct. Ritvik, magnesium is correct, iron is correct. Tanisha, check the, like keep the reactivity series with you, like refer to it once again, try again. Neil, all are correct. Rishita, check again. Shakti, iron and aluminium, you got it. Anirban, yes, aluminium wala, you got it. Deshna, iron, you got it. Okay, a lot of you, it's like divided 50-50. Some people are getting it, some people are not. So these two, most of you are getting it right. But one thing I want to tell you guys, don't just blindly exchange it and write the equations, okay? Check what elements you're given here. So between magnesium and sodium, which is more reactive?
Ma'am, I sent it to you on WhatsApp.
Sodium.
So if sodium is more reactive, can magnesium push it away from its base?
Ma'am, no reaction.
So this is no reaction. So don't just blindly exchange the ions and write, okay? Like if you are confused, if you don't know which is more reactive, less reactive, keep the reactivity series with you until you guys get the hang of it. But focus. Don't just blindly exchange it and write it off. Okay, that's one thing.
Ma'am?
You send it on WhatsApp, right? I'll check it.
Yes, ma'am.
Yeah, you corrected it. Yeah, otherwise, yes, all of it is right. Okay. Iron and copper sulfate. This also, you've got lots of practice with this equation. You get FeSO4 plus Cu. Aluminium and this thing also, most of you have got it. Aluminium will displace Al2O3 plus Fe. Okay. This is like industry in real life wise, this is an important reaction. So we're going to talk about this reaction. So let me know when you are done noting it down and we'll talk about it.
Ma'am, isn't aluminum oxide used to prevent corrosion?
That is
It's
only in the
applied
case of
on-
aluminium. Only when you have like
Yeah.
aluminium, you coat it with aluminium oxide to prevent corrosion. So this reaction is used in a different context. Mansi and Jaden are done. Jasmine's also done. Whoever
ma'am.
has sent an answer, can I assume that you guys are done noting it down?
Yeah, ma'am.
Yes.
Okay. So, who hasn't sent your response yet? Sarah has sent in. Okay, got it right. Shakti, Rishika, Neil, Tanisha, Ritvik, Sudha. So, Abhishek Trivedi has not sent it yet. Amey has not sent it. Snehal, have you sent it? So guys, whose names I'm calling out, let me know if you have noted down the reaction. Abhishek, Amey, Snehal, Ryan. Okay. Cool. You guys are like really quiet. Like I don't know if things are clear or no. What's
Done, ma'am.
okay. Rishita, fourth equation, is it balanced or not balanced? Check. So एक aluminium, दो aluminium है. So it's not. So this will have to be 2. 1 iron, 2 iron. So this will have to be 2. 3 oxygen, 3 oxygen. Yeah, that's it. Cool. So this particular reaction, right? So specifically iron oxide, Fe2O3 plus aluminium gives aluminium oxide plus iron. So this reaction is extremely exothermic, produces a lot of heat. So it produces so much heat that whatever iron you get, right, you get it in liquid form. So you take solid form, you heat it so that, give it a little spark so that the reaction takes place. And you get iron in liquid form. Aluminium oxide, I think it's liquid or solid. I have to check. I think it's solid only. But yeah. So this mixture of aluminium plus iron oxide is called thermite. And this reaction, this particular reaction is called thermite reaction. And because you get iron in liquid form, there is a use for it. So this particular reaction is used in filling cracks in railway tracks. Oh, that rhymed.
Ma'am, have you written Fe is liquid?
Yes. So that's what I'm saying. Like this reaction is extremely exothermic. So exothermic matlab, there's so much heat that is released that whatever iron you get, like iron metal is molten. You get it in liquid form. Yeah. So because you get iron in liquid form, so basically what happens is, let's say you have a railway track and there is a crack here. Okay. Obviously, having cracks in railway tracks is dangerous, right? Like, you know, trains get derailed, anything can happen.
Yeah.
So if you want to fill this crack, a lot of times these cracks can be really tiny. Okay. So what you do is you take like a vessel sort of a thing, and there is like an opening that you can control. So you fill this vessel with thermite mixture. Thermite mixture is basically mixture of iron oxide and aluminium, and you give it some heat. Like take like a flamethrower, lighter, whatever. You give it heat. So that gets this reaction started, and there's a whole lot of heat here. And during this reaction, whatever iron is produced is molten. So when you open this tap, the molten iron trickles down, fills up the crack, and yeah. So whatever, you know, you can control the flow so that, you know, you fill up how much ever is required for the crack, and you can shut the rest. And that is how, you know, thermite reaction is used.
Can you repeat? I did not get it.
I'll show you guys a video also. So 3 points to it. One, this mixture is called thermite reaction, THERMITE, thermite mixture or just thermite. And the reaction that takes place is called thermite reaction. Second point, this reaction, it's a displacement reaction where aluminium displaces iron from its oxide. And this reaction is extremely exothermic. Exothermic matlab, so much heat is produced. So much heat is produced that heat is sufficient to melt whatever iron is produced as a product. So you get iron in liquid form, you get molten iron, you get lava basically. Okay. So the third point, because you get iron in liquid form, this reaction is used to fill cracks in like things like railway tracks, in like iron and steel things.
So, ma'am, you can't do this in a test tube.
You can't. Can you repeat that? Where can we not use it?
You can't do this in a test tube.
No, definitely not. You can do it, but it's advised that you do it in an open place. Like, don't do it indoors. And you can still create the safety thing by, you know, taking a limited amount. If you take it like, you know, in terms of like 5 grams or 10 grams, tiny quantities, you can still do it, but it's not of any use as such. Like for practical purposes, yeah, you do it in like outdoor areas. Yeah. Puneet, does the theory make sense? Like clear about it now?
Yes, ma'am.
Okay, so I'll show you guys a video about thermite, this thing. How much time do you guys spend on YouTube? Like, do you watch it often?
Yes, ma'am.
I've been bored.
You're bored. Okay. Have you guys come across this channel called The Backyard Scientist?
No, ma'am.
No?
Yes.
Oh, some of you have. So he does all these like really crazy chemical experiments in his own backyard. Obviously comes with a disclaimer, not everybody can do it. So yeah, he also has done this thermite reaction, but you can see here, thermite, railroad thermite welding. So this is one thing. So you can see that, there's like continuous fire. So there's reaction going on and the cracks are filling up. Let's see which is, let's look at the demo.
Good grammar and
Ma'am, backside scientist.
but if you want to write essays that inspire.
Yeah, Puneet, what do you say?
Miss, what channel name you tell?
This channel is this is some university ka OSU chemistry. The one I was talking about is called Backyard Scientist. He does like reactions with dry ice, liquid nitrogen, all of that stuff.
Oh, hi. I'd like to do a little demonstration as a mixture of two solids. Cans have all kinds of been ground up into the powdered form, and that's known as rust. This little porous cup. People put soil and little seedlings and samplings and things inside there, put it in the ground and let it grow. Well, I've got the solid inside here and a little 4th of July sparkler. And the 4th of July sparkler will throw some sparks down in the mix, give it the activation energy to go. This is an extremely exothermic reaction, so heat will be given off. Our products are going to be iron, solid, and some aluminum oxide. This temperature that we reach is going to be hot enough to melt the iron product that we go ahead and make. So let me get this started. I'm going to light a little Bunsen burner here. Light the sparkler. So at the beginning, you'll know that it's just sparks. And when this puppy goes, you're going to know that it's more than just the sparks. That's molten iron that's dripping out of the bottom there. That's liquid iron. The cat food can underneath it is just for effect because the iron just ripped right through that aluminum can and it's kind of on fire. Down below in the bucket is some sand and it's catching the iron so that it doesn't go into water or hit the table or something like that because it's at about 3250 centigrade. It's very, very, very hot.
Okay. Did you guys get that? Were you able to hear the audio?
Yes, ma'am.
Yeah, ma'am.
Okay. So that is thermite reaction. Like if you want a replay of it, you can see the difference as he said. So when it was a sparkler, there was like some amount of brightness, but once it hits that mixture of aluminum oxide and iron, you can see that literal explosion there, lots of heat. And then he also showed that, there was literal lava flowing. That's basically molten iron. Just replay it again.
Know that it's just sparks. And when this puppy goes, you're going to know that it's more than just the sparks. That's molten iron that's dripping out of the bottom there. That's liquid iron. The cat food can underneath it is just for effect because the iron just ripped right through that aluminum can and it's kind of on fire. Down below in the bucket is some sand and it's catching the iron so that it doesn't go into water or hit the table or something like that because it's at about 3250 centigrade. It's very, very, very hot. It's just now cooling down. Extremely exothermic reaction.
Yeah. So in case you didn't catch that temperature, yeah, the heat is so much that the temperature inside the reaction vessel, like wherever the reaction is taking place, it goes up to like 3250 degrees Celsius. So it gets that hot there. Melts iron. Okay. So that's thermite reaction. Like if you want, I can show you guys the practical this thing, how they use it in the railroad.
अच्छा लगता है जब प्रिस्टीन केयर से सर्जरी करवाकर लोग अपने घर जाते हैं। इसी ट्रस्ट के साथ प्रिस्टीन केयर के एक्सपर्ट डॉक्टर्स हर्निया, पाइल्स, कैटरेक्ट जैसी 50 से भी ज्यादा बीमारियों की सर्जरी करते हैं। सर्जरी मतलब pristinecare.com।
Yeah, there's not much to look at because everything is taking place inside. But you can see how hot it's getting, like just fire everywhere. There's molten iron dripping down from the that's used to. There you go. See just that molten iron out from there. Molten iron here too. Excess iron. Ensure that iron goes where it needs to, wherever it needs to, like get filled up, and it doesn't leak all around. So we'll let it cool because you can't take it immediately, else the iron's gonna leak everywhere. Let it cool and then separate out that mold. Yeah. So that's thermite reaction. So that's like an application of your displacement reaction. So aluminum oxide plus. It was iron oxide plus aluminium. So aluminium displaces it and iron comes out as molten iron, and that's used to fill up things like make molds out of. That's how it's applied. Shakti and Tanisha, you guys have your hand raised. What's up?
No, I was just raised.
From the so we have the reactivity series arranged in the order of decreasing activities. We've seen the reactivity series. Oh, and then there's this last part of it. How do metals and non-metals react? So if you have a metal and a non-metal and you need to form a compound from the metal and non-metal, how do they react? Like we've done the whole chapter, you guys. We've done like a lot of sets of reactions. What kind of compounds do metals?
Can you repeat your question?
Yeah, so I was asking, how do metals and non-metals react? Like if you have a metal and a non-metal and they both form a compound, what kind of compound do they form?
Salt.
Salt, yes.
Some
But
salt.
what's the chemistry behind it? Like how is a salt formed? Is it ionic? Is it covalent? Is it like
Ionic?
Ionic.
Ionic, absolutely.
Some ionic.
And what do you mean by ionic compounds?
Exchange of electrons.
No.
Isn't it the exchange of ions?
Ions don't exchange. Ionic compounds are
Ma'am,
compounds.
it's like
transfer of
the
electrons.
cation from the metal and the anion from the non-metal, and something else. It doesn't meld into one thing and happen.
Very nice. Yes. Meld is not the right word. You can say bond. Like they're attracted to each other. Use those words. But yeah, essentially you guys are right. Puneet, you said a really interesting thing. that's a huge misconception, I would say. Exchange of electrons, it kind of looks like that, but that is not what is happening in ionic compounds. So cations or metals tend to lose electrons on their own, like because that's their tendency, they are electropositive. And anions tend to attract electrons on their own, like that's because that's again their tendency. But it's not necessary that a cation has to give electrons to the anion. So that exchange doesn't take place, just that metals turn into cations, non-metals turn into anions, and because they are oppositely charged, plus and minus attract each other. Okay. So the way it's given, like the way you have to present it, how do metals and non-metals react, or how do they form compounds, is metals plus non-metals essentially form ionic compounds. So ionic, again, it's in the name. Ionic matlab, it's made up of ions. So the first step when metals and non-metals react is the formation of ions. Okay, so if I were to take the example of magnesium oxide, so formation of ions, let's take cation first. So in magnesium oxide, it's made up of magnesium and oxygen, right? What is the electronic configuration of magnesium?
Ma'am, 282.
282, atomic number 12, so it would be 282. So what kind of ion will magnesium form?
Cation.
How many electrons will it lose to form the cation?
2.
And 2 electron.
Yes. So magnesium loses 2 electrons. So this is the reaction. Magnesium turns into Mg2 plus, gives out 2 electrons. The other thing that we have is oxide. So the anion is oxygen. Oxygen ka electronic configuration?
-2. 2 minus.
Ma'am, 288.
Sorry, 286.
286.
26.
Yes, ma'am.
26.
26.
Oxygen is 8 only, not 16. Yeah. So what will be the formation of anion? So how will oxygen form the anion?
It will gain electrons from a cation.
Again, Shakti, that's a misconception. It's not necessary for a cation to be present. Like you guys have gone through displacement reactions also, right? यहाँ पे कोई losing gaining नहीं हो रहा है. Yeah, sodium is losing, yes. Iron also is essentially already a cation. So this is just taking the electrons from wherever available, and sodium being positive, sulfate being negative, is they both are attracted to each other. But it's not like sodium is giving electrons to sulfate, right? So anions, not necessary that cation always gives it to the anion. Cation,
Okay, ma'am.
it loses electrons, this gains electrons. So it gains 2 electrons to form O2 minus. And the second step is the cation, like positively charged cation and negatively charged anion, are attracted to each other to form the ionic bond. And how are they attracted? Like what is the core of ionic compounds? Like what is the force that attracts the cations and anions?
Kinetic energy.
Kinetic energy.
No, but I actually don't know. I think it's kinetic
Opposite
or
forces,
potential.
opposite, like they attract each other, right?
Yes, opposite force, like opposite charges attract each other, and charges के बीच में जो भी force होता है, what is that called? See, if it is surfaces, you have frictional force. Agar if it's masses, like the way the sun holds the earth, earth holds the moon, you have gravitational force. That way, if it is two charges that are being attracted or repelled by each other, what is that kind of force called? Electricity, kind of, like the word contains.
Electrostatic.
Awesome. Yeah. So they are bonded by something called electrostatic forces, like in this case, attraction. Okay. So ionic compounds are formed because the cations and anions, like oppositely charged ions, are attracted to each other due to this electrostatic forces of attraction. So it is because of this force that ionic compounds have all their properties. They're like really tightly, attracted to each other. Okay. So though magnets ke beech mein do force hota hai, that's magnetic forces. If it is due to masses, it's gravitational forces. If it is due to charges, that's electrostatic forces. Cool. So how do metals and non-metals react? Step 1 is they form their respective ions. Step 2, they're attracted to each other by electrostatic forces of attraction. Yeah, Aditya.
In the last slide, the thermite reaction, you had made a diagram. So that type of diagram, do we have it in NCRT?
No, I don't think.
Or like in
I
a
just did it
syllabus?
to show you guys, but then after that I showed you the video anyway, so you don't have to draw the diagram. Well, keep in mind your pattern has changed, guys. Abhi MCQs aane wale hain, so you won't have to draw diagrams. And if you were to identify,
They can ask what the parts are or what is happening.
हाँ, उतना details नहीं होगा. If at all you're given something, you'll be given other details. Like you may be shown that this vessel has a mixture of aluminium plus iron oxide. So usse you should be able to identify that thermite reaction. Yeah. So exclusive like bio jaise diagram pe focus nahi hoga. Like you'll have like other clues given to you.
Okay, ma'am.
Okay, so this is how the ions react, and we'll quickly discuss the properties of ionic compounds. Actually, do you guys know the properties of ionic compounds? Can you say it?
Could you repeat the question?
Yeah, do you guys know the properties of ionic compounds?
They're stronger than covalent bonds.
Absolutely. So ionic bond stronger than covalent. So isliye what kind of properties does that give rise to?
They have electric charge.
Okay. They're made up of ions. So yeah, charged particles. But ionic bonds are stronger than covalent bond. So because of this, what is the physical state of ionic compounds? Are they like physical state matlab? Will they be solids, liquids, or gases at room temp?
Liquid.
Solid. Solid. Mansi got it. She sent it also. Anirban, think of ionic compound matlab table salt. So NaCl is ionic, right? You have Na plus and Cl minus. So NaCl कैसे होता है like box में? They are in solid state. Second, what sort of melting points, boiling points will they have? Like really high, really low?
Really high.
High.
Ma'am, in solid they will really high.
Yes.
Because it'll take a lot of energy to break the bonds.
Correct. So electrostatic force of attraction are really, really strong. because they're really strong, it gets a little difficult to break those, you know, intermolecular or interparticle forces. So that's why they end up having high melting point and boiling point. Are they soluble in water or insoluble in water? Can they dissolve easily?
No, ma'am.
No, ma'am.
No.
Yeah, NaCl.
Think of salt. Like, have you ever put salt in water?
But ma'am, some, right? That won't be the case for all of them.
Yeah, most of them dissolve in water. And even those that don't dissolve, no, it's not because of the ionic nature. It is more like a case-to-case basis. Like, there's other factors like hydration, energy, and all come into picture. So most of them are soluble in water. Ionic compounds, now because of their ionicness, that tends to make them dissolve in water. Soluble in water, but insoluble in, like, can you dissolve salt in oil?
No, ma'am.
Yeah.
No, ma'am.
They are not soluble in organic solvents. Yeah. Next, what can you say about the conductivity?
Because they are made of ions, they do conduct electricity.
Okay. Will they conduct electricity in solid state?
No, in aqueous form.
Are they good conductors in solid state?
I guess some are.
Like, you need to back it up with a solid reasoning.
I don't know.
No?
Ma'am, can you repeat your question?
Yeah, I was asking, are ionic compounds good conductors in solid state? Okay, let's break it down. Electricity conduct करने के लिए, what is important? What is required?
Ions.
Ions, yes. Also, what is electricity itself? Is it like just presence of ions or is it something else? Elena has said, yes, movement of electrons, right? So movement of, let's say, charged particles. Electrons ho sakta hai, absolutely right, but otherwise could be ions also. In solid state, are the charges capable of moving ionic compounds mein?
No, ma'am.
They're not.
They are like that.
No, ma'am.
They're fixed. That's the property of solids. So will they conduct electricity in solid state?
No, ma'am. They won't.
They will not. So solid state mein, they are not conductors. They don't conduct any electricity. But if you dissolve them, aqueous state, will they conduct?
Yes, ma'am.
Very nice. Because when you dissolve them in water, the ions are breaking down. Like, it won't exist as NaCl, it exists as Na plus and Cl minus separately. And pani mein hai na, so pani mein it can, like, they can flow easily. There is movement of charges. So isliye they are good conductors. And what about molten state? Matlab, when they are liquid. Are they good conductors or they will not conduct?
Then they could conduct, I hope.
Think about it. Like, liquid state may, will the ions, like, are they freed up enough to flow? All you need is the ions to be able to flow. So when you melt the solid, can they flow?
No, ma'am.
No.
No. What are the properties of particles in liquid, like are they rigid or are they fluid?
Fluid.
Flowing.
Fluid.
और fluid
Fluid.
का meaning क्या है? Like fluid मतलब are they able to move, like flow, or not able to?
Yeah.
They're able to flow, right? So
Flow.
if I melt salt,
So,
like put it in liquid
yeah.
state, then will it be a good conductor or no?
Yeah.
Yes, ma'am.
Good conductor. Yeah. So this gets important when we talk about, you know, extraction and all these different things. So in solid state, they are not conductors because the ions are like tightly packed and they absolutely cannot move. But if you dissolve them in water, the ions are like dissociated, like that's how your reactions happen. So isliye, because they are loosened up and they are able to flow, they can conduct electricity. It's basically flow of charges. So they become good conductors. And also when you melt them, like when they are in liquid state. So Shakti, you said if they reach high enough temperature, right? So that temperature is the melting point. So beyond the melting point, if they are already liquids, then they become good conductors again. Okay. So these are like some of the major properties of ionic compounds. I'll just check if, yeah, one more property is that they are brittle. So it's like all these are like metals where they're solids, they have high melting boiling points, even in terms of conductivity. But metals have high tensile strength. Ionic compounds are brittle. So brittle matlab, if you have a solid chunk of this thing, if you put a hammer to it, they crack, they break easily, like a chip or a biscuit. So they crack or break easily. Ionic compounds are usually brittle, not strong. Okay. So that brings us to almost the end of the chapter. There's a little bit about extraction. So tomorrow maybe I'll spend like half an hour or something. You guys don't have to note anything down. I'll just give it to you like for your information type of thing. And I think we'll also discuss about alloys and alloying and corrosion and all of that